Got a good group here, it looks like. So thank you very much for joining us for our, what's this, fourth installment of our Lunch and Learn series with the Food Innovation and Business Hub. Really great topic today, Food Safety 101, something that we all are should be concerned about, I guess, in our daily lives, but also in our food business lives. So, our presenters today, we have Hannah Hansen, who's a food safety extension specialist, and Sarah Pirtles, an education specialist. Both of our presenters today work with us in the Food Innovation and Business Hub and are also Iowa State University graduates and have both focused on food safety in some of their graduate work. And so they're going to give you an overview. And I think Hannah or Sarah will probably say this. This is meant as a primer. This is kind of an intro. There's a lot of information on food safety, and the Food Innovation and Business Hub will continue to bring you education opportunities for that other kind of information that you may need depending on your situation. All right, I'm going to pass it over to Hannah and Sarah, and we will, and feel free to use, I'm going to say the chat function if you have any questions, and we'll make sure we get those answered at the end of the presentation. Okay, take it away, Hannah and Sarah.
Thank you, Erin, for the warm intro. Excuse me. As Erin mentioned, we work for the Food Innovation and Business Hub, and this is just a primer on food safety, and please use the chat for your questions. So let's go ahead and get started. So, something that we all know from experience is that all food spoils and has a shelf life. Whether it's a cracker sitting in your pantry or fruit, given enough time, it will eventually break down and deteriorate. What really matters in terms of food safety, though, is the rate at which this occurs and also the harmful microorganisms that can inhabit foods. For example, bread versus chicken breast left on your counter. The bread will take a few days before it gets stale if it's left unopened, and it'll take a week or two before it starts to get moldy. However, a piece of raw chicken, when left on a counter, will become dangerous to consume within a couple of hours, or even less. Humans have known about spoilage for thousands of years, and we've known of different ways to preserve foods even before we understood why and what was responsible for making them unsafe. This includes canning, drying, fermentation. All of these are methods to extend that shelf life and delay microbial growth. So, what exactly causes food to spoil? So, food is made up of a complex matrix of interactions, and our focus today is on unsafe food. However, food spoilage is driven by a few different things, including microorganisms such as bacteria, yeasts, and molds, enzymatic activity, which results from naturally occurring proteins in the foods changing that food matrix. Chemical reactions in food can also cause food to spoil, and some of these are driven by those enzymes and environmental factors occurring. Sorry, I skipped a slide there. Take, for example, enzymes. An example of this would be apples. They brown when they're cut. This is due to an enzyme called polyphenol oxidase in the apples reacting with oxygen in the air to create that brown pigment. Chemical reactions could be oxidation of fats, which cause food to become rancid. The focus, like I mentioned, is on the microorganisms today in terms of food safety. However, physical and chemical contaminants can also cause foods to become unsafe. When we talk about unsafe food, the culprit is most often microorganisms that we call pathogens. These are microorganisms that can cause disease. Some examples of pathogens include viruses such as norovirus, which is the leading cause of foodborne illness, and vomiting and diarrhea. It's what we refer to as the stomach flu. However, it's typically due to norovirus. Bacteria including Salmonella and Listeria monocytogenes, and parasites, which are, in the case of Toxoplasma gondii, this is a parasite that can be transmitted through undercooked meat. And pathogens are of particular concern to immunocompromised individuals, pregnant individuals, infants, and the elderly. So it's really important to make sure that these pathogens don't grow or are inhibited in some way in your foods. So foodborne illnesses can reach us in two main ways, either by consuming the microorganism itself or by the toxins that they produce during their microorganisms' growth in food. In the case of toxin producers, the most notorious one is Clostridium botulinum, which is responsible for botulism, although Staphylococcus aureus is much more common and is even present on some people's skin. So it's very important to make sure that these, microorganisms don't grow in your foods. Whether bacteria are multiplying and releasing the toxins, the outcome is the same. You get sick. Most foodborne illnesses are unpleasant, but they're manageable. There are 5 signs of severe food poisoning, however, and if you have any of these, you should definitely see a doctor. Vomiting so often that you can't keep liquids down. You become dehydrated as a result. Little to no urination, dizziness, high fever, higher than 102, bloody diarrhea, or diarrhea more than 3 days. So these are important signs of food poisoning that you should absolutely see a doctor for. Now I will hand it over to Hannah, who will discuss microorganisms at play.
So microorganisms are responsible for these very unpleasant symptoms. And so for us, when we think about food safety or being a food producer, we have to take the extra effort to understand what microorganisms are and how we can control these. Unfortunately, microorganisms are essentially everywhere. The slide earlier showed the relative size of a microorganism to a human hair. So they're very, very small and can't be seen with the naked eye. They're on us, they're on surfaces. Thankfully, most microorganisms are harmless and don't really have an impact for human health. And we actually use some for helpful things, such as fermented foods. I know a lot of my favorite foods are fermented, but because there are a few out there that can cause illness, injury, or harm, or death, we have to be cognizant of that in our food and make sure we have the proper controls in place. And again, because they're everywhere, they can come from the ingredients themselves. Most ingredients are grown outside or raised outside and exposed to the elements such as water, soil, and air. And those can contribute to microorganisms on those things. And with that, we have to ensure we have the proper controls in place. Next slide, Sarah. So with microorganisms everywhere, how do we keep our food safe? The common terminology we see is prevention, eliminate, and reduce. With these 3 strategies, we're able to ensure safe food. But it's very important to understand of the microorganisms that cause harm, there are certain foods and operations that are more likely to experience certain types of microorganisms, and that can help us have a specialized approach to what controls are important for our food. If we can understand microorganisms and their requirements, then that will be extremely helpful in that. And so when we think about microorganisms, we can think about them being a lot like us. They are, they require a food source, just like we do, and they can use the same nutrients that we have in our food to as a food source for them. And go ahead and continue forward. And so to help us understand what microorganisms are looking for and what the requirements are, it's helpful to have an acronym. And typically you might see FAT-TOM or FAT-TO, and we'll get to why we have a W versus an M here to help folks think about their food and think about how to keep it safe. When we look at this FAT-TO acronym, F is for food. And when we think about food, again, we can't remove the nutrient source that is there. We are driving nutrients from this food, as well as bacteria can use the same sources for their energy source. But the remaining parts of the acronym we are able to use to help us control microorganism growth. Acidity, pH, time, temperature, oxygen, and water activity. And these are the parameters in food processing or food production that we can utilize to address pathogens that may be in the food. Next slide. So we're going to talk through each one of these. Again, very briefly, this is a very high-level overview. Lots of resources out there to continue to learn, as well as the hub. We're happy to help folks understand these concepts further, as well as understand maybe how to strategize with their product and ensure safety. So we talk about acidity, we're really talking about pH. This is the way we measure acidity. pH is a measure of how acidic or alkaline a substance is. It's on a spectrum from 1 to 14, with the middle of the spectrum being neutral or 7. Microorganisms being a lot like us, they have preferences for each one of these. And so when it comes to pH, microorganisms typically like to be kind of in the middle of the spectrum, maybe slightly under 7, but generally speaking, they like a neutral pH. Again, there's lots of microorganisms out there, and some can have adapted to survive at other pHs, but this is a general thing we can kind of think through when we're thinking about pH. When we talk about pH as a food safety control, we're going to hear the number 4.60 heavily. And that's because when you get a product below this pH, typically that will be a sufficient control to stop microorganism growth. To give some perspective on where foods fall, if we can go back a slide, Sarah, where foods fall on the pH spectrum, a lemon is something that you can consider very acidic. It's typically in the range of 2 to 2.6. If you think about a lemon, it doesn't necessarily spoil quickly, whereas we have something like milk that's in more of the center of the spectrum, which is highly perishable. So pH is not something that helps to prevent microorganism growth. I also like to point out tomatoes, because tomatoes, depending on the variety and growing conditions, can kind of ride the 4.60 line. So it's something to be aware of if you're working with tomatoes, that pH can vary based on growth conditions, as well as variety that you're using. Next slide. The next part of the acronym is time. We're going to talk about time and temperature separately, but generally speaking, when we talk about how to keep food safe and how to drive control of microorganisms, you typically pair these two together. But generally speaking, microorganisms need time to multiply or grow in number. And the more time that we provide to them in favorable conditions where they can grow, the more microorganisms we're going to have, and the more chances or probability there is for getting someone sick. Some microorganisms can double in 15 to 30 minutes, and you might think, well, that's not a crazy amount. But when we talk about microorganism growth, we typically talk about a growth curve that's showed here on the slide. We typically see microorganisms go through a lag phase, a log phase, a stationary phase, and a death phase. And the phase that we're very focused on from a food safety perspective is the log phase, or the exponential phase. Typically, if we can avoid getting to that, that's really good news for us. Next slide. If we get to the exponential phase of growth for microorganisms, we can see that in a very short amount of time, just hours, we can go from a few bacteria cells to thousands of bacteria cells. And again, if we think about going from 1 to 2 to 4, doubling every 15 to 30 minutes, we have high numbers of bacteria very quickly. It's also important to consider that some pathogens do not need very many cells to cause illness, with some being just a couple to make someone sick. So just even a few cells can be problematic for food safety. Next slide. Temperature is another parameter that we consider when we're looking at microorganisms and food safety. Again, just like everyone's household, they have a preference for a thermostat. They have ranges where they can grow really well and ranges where they might slow down a bit. So we talk about temperature, we think about it in two different bullet points. We think about cooling and heating. So typically when we talk about heating, we're talking about heating to destroy microorganisms. So something like cooking is going to destroy microorganisms, whereas cooling only is going to slow them down. Also with temperature, we need to be very cognizant of the temperature danger zone. This is a range of temperatures from 41 degrees Fahrenheit to 135 degrees Fahrenheit, where many microorganisms can grow very well. And so typically this is a temperature range you want to minimize time in. If we think through many of the food regulations out there, as well as tons of scientific literature, we typically see requirements for how much time you can spend in certain temperature ranges. And so this is what really drives that, is we're trying to minimize the microorganism's ability to grow to any number that will cause issues. Next slide. Another consideration when we talk about microorganisms and how to control them is oxygen. Oxygen being present can be a great thing for some microorganisms, whereas it can poison others. Microorganisms, again, have preferences. And so when we look at certain types of food preservation methods, some will remove oxygen and some inherently will remove it, such as canning. But this will change your focus on which microorganisms are of concern and which ones might be able to grow and cause issues. Next slide. And our last consideration, which sometimes is represented as an M for moisture or moisture content. I've flipped the M upside down because when we look at moisture, water is important for all living things and microorganisms are no exception to this. But when we talk about the moisture or water in a product, we are only concerned with what water microorganisms can use. If the microorganisms cannot use it or it's unavailable to them, then it's not going to contribute a concern to microorganisms. And so water activity is a helpful measure in food safety because it is only going to measure the water that is free or available to the microorganisms for use. Water activity is a ratio, so it's on a scale from 0 to 1. 0 being no free water, 1 being water, essentially, so completely water. And as you get higher as your water activity increases, your amount of free water increases. Typically, when we talk about food safety controls related to water activity, we see the limit of 0.85. And so typically to preserve a food, we want to see that water activity taken below that to prevent microbial growth. A common practice with water activity, sometimes we see methods that remove water, and Sarah's going to talk more about preservation, some common preservation methods, but we also see where sugar or salt can be added to essentially transform free available water to water that is no longer available for microorganisms to use. Next slide. For water activity, I really want to accentuate that water activity and moisture content are not the same thing. If you are using moisture content to ensure safety, likely this is not the best practice. We really want to lean into water activity. So when we talk about moisture content, we're looking at the total water in the product, and this is the water that's both available to microorganisms and the water that's unavailable to microorganisms. Water activity is going to only look at the water that's available to microorganisms. And as we look at the table here, we can see a change in product essentially for meat and produce. We can see the change in reduction in water activity and reduction in moisture content. Again, these likely will follow similar trends, but again, they're not always related. And I threw peanut butter in there because I think that one's a very interesting one to look at. Peanut butter has a lot of components that are not moisture, and so that's why we see kind of a funkier relationship there. But generally speaking, when we preserve the product, so example going from raw beef to salami or raw fruit to a dried fruit or a jam or a jelly, we see that water being reduced as or converted from water that's available to water that's unavailable. Next slide. So when we are thinking about microorganisms and how to preserve food safety, we need to think about FATTO. So hopefully you can walk away with that and feel good about remembering that acronym. It's very helpful when you start looking at a food product to understand what are the potential things I can look at and what are the potential things I can measure. Acidity and water activity are extremely easy to measure. That's something our hub can do for you, as well as there's the ability to get some of those instruments at home as well. But these are great tools to help ensure safety, and they're the things that we can drive to drive controlled microorganisms. Next slide. The last thing I want to close with on the microorganisms part of the discussion is that bacteria and microorganisms as a whole will adapt. So depending on their environment, they can change what they're doing to utilize different energy sources. They can become tolerant. So it's always important to make sure you're looking at microorganisms with someone who understands that and can help you understand that. The parameters we talked through don't all destroy microorganisms. So we talked through that cooking will kill the microorganisms, and dead pathogens are not going to cause illness. But if they have the ability to survive, a good example is salmonella can survive long periods of time in dry products. So if you buy a dry seasoning mix that potentially, let's say, had salmonella that survived a long time, a lot of us take seasoning and throw it into sour cream for a dip or something. You now have provided the environment for that salmonella to start growing again. And so we have to be cognizant of if our control is destroying or just preventing growth. Also, microorganisms are very, very smart. They have tools that they can utilize to survive. Spores are something that the way I think about it conceptually is they're kind of going down into their bunker and going to survive these really abrasive conditions. So a good example is during canning. Certain bacteria can form a spore that they will kind of hunker down until conditions are favorable again. Also, biofilms can build up on contact surfaces. Again, it's a way for bacteria to survive and to find a way to continue on. Stopping growth in the food is extremely important. Consuming the living cells, living or vegetative cells, is not good. But if we also provide the opportunity in the food, some microorganisms can produce toxins. And you might think, well, I'm going to cook it, so what's the big deal if this happens? The thing is, toxins can be heat stable, meaning that heat's not going to destroy the toxin. Some bacteria have actually shown that the toxin is stable in canning. And if you think about how abrasive canning is, and that toxin can persist and then make someone sick once they consume it, that's extremely important to prevent that. And then ultimately, what you decide to utilize is really going to depend on your product and your facility. And it may be that you want to use more than one. Having multiple controls is never a bad thing. That way you have multiple hurdles that have to be bypassed in order for a microorganism to persist. So, next slide.
So now we're going to discuss a few examples of how to apply these hurdles and some food preservation methods. So one of the most effective and oldest methods of food preservation is controlling acidity. So when the pH, as Hannah mentioned, of a food drops low enough, it creates an environment where harmful microorganisms can't survive or grow. There are a few ways that we can achieve this as food producers. Acidification involves adding acid, such as vinegar, to a food to lower its pH. An example of this would be canned pickles. Fermentation is another process where beneficial microbes produce acids as a byproduct of their own metabolism. This is a good example of this would be sauerkraut, kimchi, or yogurt. Formulated acid foods are products that are manufactured to achieve a specific pH level. This includes some sauces, such as barbecue sauce or hot sauce. Below a pH of 4.60, most harmful microorganisms can no longer grow, and this includes one of the most dangerous pathogens in food safety, which is Clostridium botulinum. This is responsible for botulism. Its toxin specifically is responsible for botulism. So at a pH that's under 4.60, Clostridium botulinum cannot grow and cannot produce its very deadly toxin. So acidity and controlling acidity is a very critical hurdle in food processing for this reason. Another foundational food preservation method is controlling time and temperature. So we are all familiar with doing this day to day, whether we know it or not. Refrigeration and freezing are examples of this. So how does this control food spoilage? Refrigeration and freezing don't eliminate pathogenic bacteria, but they do slow or stop their growth. Refrigeration, again, will slow growth. Freezing extends shelf life significantly of food products, but once a food thaws, that clock starts again. And this brings us to a very important concept from the Iowa Admin Rule, time and temperature control for safety foods, or TCS foods. These foods are those that require time and temperature to limit pathogenic microorganism growth or toxin formation. This does not include foods that have that lower pH, less than 4.60, or water activity below 0.85. Some examples of TCS foods are any animal foods really that are raw or heat treated, including meat, poultry, seafood, eggs, dairy, and also any plant foods that aren't heat treated or are raw seed sprouts, for example. These must be refrigerated for them to remain safe. They're very well known for causing some outbreaks in the past in like different restaurants and such. Any fruit really that's cut, including melons, tomatoes, cut leafy greens, or garlic and oil mixtures. These are more vulnerable to spoilage, so they must remain refrigerated in not in that 41 to 135 degrees to remain food safe. Another powerful tool in food preservation is controlling oxygen. As Hannah discussed, some microorganisms that cause spoilage and food-borne illness need oxygen to grow. And so if you remove the oxygen, you remove that environment that allows them to thrive. So there are several ways that we can do this, and that many food producers rely on. Vacuum packaging, for example, is when air is pulled out of a package, and that creates a low oxygen environment. So most microbes cannot grow. Meat and cheese products are a good example of vacuum packaged products. Modified and controlled atmosphere packaging are more sophisticated approaches that kind of rely on this same thing. So rather than just removing oxygen, they'll replace oxygen with a blend of gases. Typically, one of them is carbon dioxide. So that will slow microbial growth, but also maintain the food's color and good traits. Canning is one of the oldest and most effective examples of oxygen control. That will extend the shelf life of products when done properly for years sometimes. And finally, oil-packed food, excluding garlic and oil, helps to exclude oxygen from the surface of a food and maintain its quality. So the final one that I will be discussing is water activity. To understand it, again, as Hannah mentioned, we must know the difference between free and bound water. Bound water is water that is not available for microorganisms to use, and free water is. And so the goal of these preservation methods is to reduce the amount of free water that's available in the food for the bacteria or microbes to grow. Drying is the most obvious and straightforward example of this. And this is where free water is evaporated and removed from the food. Examples of this would be beef jerky, dried pasta, dried fruit. Freeze drying is another method that's growing in popularity. This is where the free water in a product is frozen and then the ice is removed by sublimation and desorption. So it jumps straight from the solid phase to the gaseous phase and is completely removed from the product. And this will help maintain the food, preserve the food structure and nutritional content quite well. So this allows foods to last for years. There have been people who have opened emergency rations from 40 years ago. Not saying that this is something that should be done, but they've been totally food safe. Third method is adding something to bind the water. So this would include adding sugar or salt. Sugar or salt binds to the free water and then converts it to that bound water. So this would be jams and jellies, a good example of this. So all three of these methods work to reduce the amount of water that's available in the food for bacteria. So how do we actually keep food safe? When referring to microbial safety, it comes down to, and all safety, but we're discussing microbial in this example, but it comes down to knowing what potential hazards could be present. So are there pathogens that are associated with your raw ingredients? Is your food TCS? Do you need to keep it refrigerated? This is where these controls are important and to know about. Controls must be put in place and maintained every time consistently for the food to remain safe, batch over batch. So this includes cooking temperatures, your pH targets, refrigeration, and many times multiple controls are necessary. So layering them only increases their efficacy. So an example of this would be a canned salsa. So the pH of your salsa, is below 4.60 before you can it. However, you're canning it as well, so you're removing the oxygen from that environment and creating a stronger safety net. You must, as food producers, document everything. So if it isn't written down, it didn't happen. And documentation is how you verify that your controls are working and how you can investigate when something goes wrong and demonstrate due diligence to regulators as well as your consumers. So these are very important principles to keeping food safe. So now Hannah will discuss the Food Innovation and Business Hub and how we can help with this food safety.
So we are here, the Food Innovation and Business Hub at Iowa State University. And one of our big pillars is food safety. And the best approach to food safety is a proactive one. It's not fun reacting to issues after they've happened. And so it can seem like a lot. Microorganisms are everywhere and they can adapt and life will find a way. But that's really where we come in to help navigate that. If you're just starting out and you have a recipe and, in your mind, you've been making it for years and it's been safe, likely there's something there that's helping that safety. And so helping you to understand that and helping you implement controls that can ensure you're getting that every time, because many foodborne illness outbreaks as well as product recalls happen because the thing that never could happen happened. The impossible is possible, and so having a proactive approach to ensure controls are in place is just absolutely critical to prevent harm to our consumer. And so the Food Innovation and Business Hub is here to foster economic development and food innovation through technical and business support. We want to see Iowa businesses thriving, and how we do this is through our services and programs. We have folks that can help with business coaching, that can really help you plan and execute whatever your vision is. We have an analytical lab that can run a battery of tests for you, and kind of take that a step further and help to interpret and help to understand what that means and what needs to happen going forward based on your results. Food safety support. We work with companies that are just starting all the way up to our big manufacturers to really help execute whatever food safety protocols they're needing help with. It's a great opportunity to get another set of eyes and expertise into your process. We also strive to really have strong educational programs. If you don't know, you can't do the things that can help your business or help your process and safety of your product. And so helping folks get that foundational education that's required to have a successful business. And lastly, Iowa State, as you can imagine, is large, and there's a lot of things that the university can do for you. But sometimes getting in and figuring out who you need to work with can be overwhelming. And so our goal from the get-go has been to partner with other folks in the university, such as Meat Science or Cirrus and all those contacts, to point people to the resources they need, and also for us to fill any gaps that might be there. So really aim to just help foster that development through these. A big thing that we aim to do is to connect with folks through events. So you guys are here today through one of them. On the slide, you can see some others coming up for various topics that can help your food business. Our next Lunch and Learn is going to be July 7th on Analytical Services Overview, where the lab will talk more about what they do and what support they can provide. And then our last scheduled one so far for 2026 is going to be on shelf-stable frostings. This has been an ongoing conversation for a number of years. And so we're hoping to provide a process and a path forward for those who would like to do frostings and a way to do them safely. To register for these events and others, go to our website. It's linked here to register, as well as check out any other events that might be coming up and resources that might be there for food safety and other areas that we discussed. With that, we really appreciate you guys coming and providing you guys the basics. Again, this is a very high overview of food safety, and sometimes it's hard when you see it all. We're happy to have a conversation on your specific process and product to help you understand and navigate what's meaningful and what's helpful for you. But at this point, I think we're ready for any questions.
Awesome. Awesome. Well, thank you, Sarah and Hannah, for great presentation. Lots of information. And on that note, someone has asked us if we provide recordings of the webinars, and we do have recordings of all of our webinars, of our Lunch and Learns. They should be on our, and I'm looking for them right now, on our website. There should be a link to them. And Krista, if you're still on, if you can help me point the way to those recordings. But yes, that way you can go back, review the material that Sarah and Hannah talked about today, or find the other topic. So yes, thank you for asking that, because I believe, I just want to check and see if it's on our, should be on our website somewhere. And you know, when you're looking for things and you can never find it.
And it's right on the homepage. We have
Yep.
one that
Oh,
says
great.
webinar library. So the link is in the chat as well, right
Perfect.
to the recordings page.
Thank you so much, Krista. There we go. Webinar library. That that was easy. And let me see, is there any other questions out there for Hannah and Sarah on food safety? Big topic. It's a big topic, but depending on what your business is, what your food product is, can be very specific as to what the challenges and the risks are. While I give you time to maybe type in a question, I'm just going to ask Hannah about, there's a lot of regulatory, well, let's just say there's a lot of regulatory agencies and a lot of trainings and whatnot involved in food safety at the federal level, but also I would say even at the state level, there's different licenses and different food safety regulations. Where do people start when they have the concept of, they have a food product that they want to bring to a market? And when I say market, I mean just they want to sell it somewhere, whether that's in a grocery store, whether that's actually at a farmer's market. How do they approach food safety right from the get-go, from the early days?
Well, I think the first step you have to have is what food product you're wanting to do and where you're wanting to do it at. That's going to drive a lot of the requirements for you. In Iowa, we have cottage and home-based licenses, so folks can start businesses in a home-based operation for certain things, but then there are certain products that are not able to be done, such as meat and dairy and things like that. And so honestly, the first step is figuring out your product and your process and where you're going to do it, where you hope to do it. And honestly, early on, I would seek counsel, because when we talk about food regulation in Iowa or in the country, there's 10 to 20 regulatory bodies involved, depending on where you're doing it and certain things where you want to sell it, that can drive what's the best fit and where to start. We have folks, myself included, but we have folks that have worked in this regulation for a number of years now and can really help get you going in the right direction and make sure you're compliant, but you're also producing a safe product. So I highly recommend, if you have a thought, this is something I want to do, let's have a conversation, because that's really going to help drive what your next steps are, even if it's just an idea. You know, I don't ever come to me for business advice. I'm not the business person. But that's really where the hub comes in, is we have folks in various disciplines that can really give you counsel from various vantage points and ensure you're getting started in the right direction. Because honestly, I've been in the food industry for 15 years basically, and it's a lot if you've never read regulation and practiced it. So I would not do it alone.
Yeah, it can be overwhelming coming from the fermented beverage side of things. Yeah, I've kind of been lucky to stay in that lane for a really long time because yes, there's a lot of food safety that alcohol and pH just take care of. So
Yep.
yes, please reach out to us. And I want to say too, we work together. If Hannah, if you're having a conversation with any one of us and we see, oh, you also have some questions about food safety or business support, or Hannah might point you to the lab for some analysis that will be complementary to your food safety plan. We work really closely together and coordinate those kinds of activities. So reach out to any of us. I mean, we do have a general email, but reach out to any of us and we'll get you, we're happy to get you started. And I will say Iowa specific, yes, but we do, I know Hannah has a lot of knowledge on the FDA, USDA type regulations as well. What else? I don't see any other questions, and we're getting up to the end of the hour. So I think what we'll do, again, Sarah and Hannah, thank you so much for a great presentation with lots of information. Oh, we got a question. Let's make sure we get to this. We do have some more time. So, question is, some foods are preserved by coating them with a layer of fat. That makes sense to keep water and oxygen out, but why doesn't the fat go rancid? Good question.
I'm not familiar with coating in fat, but my presumption is that there's an antioxidant in there that would prevent oxidation, and then that would help preserve that, because anybody who enjoys higher fat foods such as sausage or something, that rancidity can kick in quickly. And again, that's a very quick, fast chemical reaction. So typically in industry, when you have a high fat product, you likely will have an antioxidant to prevent that reaction from occurring.
And that brings up a great point too of something that we will definitely cover in the future is food quality and food safety and how to balance those two. A lot of times we add products like an antioxidant or an antimicrobial, and they have a quality and food safety benefit. But I think in the future that would be a great lunch and learn, or at least a webinar to discuss food safety and food quality and what that really means as well. So great question. Thanks for that one. Any others? Last call. Not seeing anybody typing. But if any questions do come up, please feel free to reach out to any of us. We are available and to take your questions and get you the support that you really need. Okay, we're gonna sign off now. Thanks again to Hannah and Sarah, and we'll see you in July, where the lab team talks about different analytical services that we offer and why you might need those for your food business. See you, everybody.